For this problem, we're looking to use the exact exposure method to estimate Q of 75. So the formula we're going to be using is 1 minus e to the negative dj over ej. Let's look at the first policy. It was issued at age 74, and the policy was terminated due to death at age 75.8. So because a person died at age 75, the death here is 1. Now we want to look at how long the person was exposed during his 75th birthday. Well, clearly, it's got to be 0.8. Since he died at 75.8, and he was there the whole time, like starting with the 75th birthday, he was there all the way up to time of death, which was 75.8. So the exposure here would be 0.8. Now let's look at the next policy. It was purchased at age 75, and the person died at 76.5. So because the person died at 76.5, that means there was no death at age 75. Right, so he was able to survive age 75. But we can look at the time he was exposed at his 75th birthday. Well, he was alive during this whole time. Right, so he was exposed for 1 year. Okay. So now let's look at the next policy. The policy which was purchased at age 75.5 and died at 75.9. Because there was a death during age 75, we say that the death is 1. There's 1 death. And the exposure, well, we have to look at the difference between the 75.5 and 75.9, which is just 0.4. So the policy was exposed for 0.4 years. Now let's look back at our formula. We want 1 minus e to the negative dj over ej. Because we have 3 different policies, we have to add them up. So I'm going to add up all the deaths. So the first policy was 1 death, second policy was no death, third policy was 1 death, and we're going to divide that by the exposure. So the first exposure policy was 0.8, then 1, then 0.4. If we add this up, we have e to the negative 2 over 2.2, and writing this out, we get 0.5971. So answer is B.